This is the first time we've done this, so welcome. And yeah, I think take it away, Michael Donnelly. He's got the slides. Go for it.
Yeah, well, so I will turn on my video. So, hey, y'all. This is our first ever office hours, and the intent of this is to just give a free forum for y'all, for everybody to ask any questions you want about Logstream. If that is about architecture and sizing, great, we'll go there. If you have questions about other things, we'll go there first. So the architecture and sizing is basically our backup plan in case there aren't enough topics and questions to fill up everything else. So we decided to make this time available for all of you. So Derek and Eugene, what would you like to get out of today?
Don't be shy.
Well, it's hard to have questions saved up when they get answered so quickly on Slack. So
Well,
I had questions, but they
I
get
was
answered.
wondering if that would happen.
Yeah, I don't have any questions at the moment. I just came to kind of see what's up.
Well, maybe this presentation will be provocative.
Might have some after, maybe. I'm
Yeah.
curious to see.
The timing is good because we are right now in the process of buying a license and figuring out how exactly we're going to deploy things. So.
Okay, cool. And Eugene, thanks for everything that MITRE does. You helped make the cyber world a little safer place.
Thanks. Not me personally.
Well, yeah, I've helped NASA, but that doesn't mean I'm a rocket science.
But I help. I'm internal IT, so I guess I support everybody at MITRE, so that counts.
Well, barring any other questions, I want to talk today a little bit about sizing and architecture, and a little bit about different ways to do deployments. So we'll just jump on into that. And if you have any questions, just take yourself off mute, interrupt in the moment. Today is as informal as you could possibly imagine. We're not here to do anything other than share some best practices and hopefully inspire some thoughts on your side in terms of different ways that you might use Logstream, either as you roll out into production or perhaps the next thing you might want to tackle after you're done with your initial deployment. So here's an example of a single worker group deployed in kind of a hybrid environment. So the intent here is to talk about all the different kinds of data sources that you might have in your coming in. So you might have things like NetFlow or syslog or SNMP traps. Those are push-based protocols where there is no inherent load balancing. And then the second would be to discuss about agents, if you will, that are inherently load balanced, notably the Splunk forwarders and Beats agents. And then finally, there are pull-based sources, things like S3 and Kafka and so forth. When we talk about bringing all this data in, you'll see that in some cases, you do need a load balancer that's external to the Logstream worker group itself. And that load balancer's purpose is to make sure that that load is distributed as evenly as possible amongst all the different workers. We don't need that for these guys over here. And you certainly don't need to worry about load balancing at all when it's a pull-based source like S3 or Event Hubs. So if you guys weren't on mute, I'd say, does that make sense? Hopefully it does. Notice that in this case, we've got NetFlow data coming in. NetFlow is a binary protocol. We don't inherently speak that ourselves. So you would need some kind of NetFlow receiver parser. And there's a couple different ones out there, one from Beats and a couple commercial versions as well. Some of those are really particularly powerful, but if that's not your data set, then it's irrelevant. Okay, so if we're taking all of this data in, I want to introduce this concept of a static workload versus a dynamic workload. So imagine I've got data coming in at, say, 4, 5, 10 terabytes a day, coming in from my universal forwarders and my Beats agents and my syslog senders and that kind of thing. It maybe goes up a little bit every morning at 8 a.m. and goes down a little bit in the afternoon. But within 10 or 20%, it's a pretty static workload. Some of the newer technologies that you might be looking at in terms of your environment include things like Kinesis or EKS if you're out in AWS land. things that dynamically and auto scale. But in the same way that you wouldn't necessarily want to auto scale your DNS servers or DHCP servers to handle additional load, you probably don't want to dynamically scale your Cribl logstream environment either for things that are a static workload. So the reason why is primarily because of these guys here in the middle. So the universal forwarders, the beat agents, they need to know the IP addresses of the systems they're sending to. Now I could scale up the number of logstream workers, make a DNS change, and then that'll roll out over the next 15 minutes or whatever your DNS time to live is. And as that happened, then those agents would pick up those new workers. But when it comes time to scale back down, that's a little bit harder, right? Are you going to shut down a logstream worker that's receiving data already? Yeah, so the idea here is that we're trying to make recommendations that will allow you to have an environment that handles your sustained workload, but that also as a separate worker group, which we'll get to here in a second, will be able to handle a dynamic workload as well. So before I move to the next slide, if you have any questions, the both of you, this would be a great time to ask.
I'm good.
Nothing at the
Okay.
moment.
Okay, so let's shift gears a tiny bit. And let's say that I had an environment where you're using the replay function of Cribl. So this is that ability to have an ad hoc batch collection job from something like Event Hubs or S3. So here what I've done is I've sized out my static worker group for my standard workload, the data that's always coming through. And to make this a little easier, in this case, I'm just making a bold assumption that S3 is only for these ad hoc batches, although in production you'd have some kind of a mix. Imagine, if you will, that this dynamic worker group sat normally with a single log stream worker and is sitting there waiting for you to do a collection job. Now that collection might be to say, look for security data from a year and a half ago, anything with this IP address or host name or username in it, and go out and, between this date and that date, collect anything at all that had to do with those IPs and usernames from that time range. Well, if you think about the corpus of data you might be looking through, depending on how you stored that originally when you wrote it to Event Hubs or to S3, you might have 10 terabytes or 100 terabytes of data that you're going to scrape through. And as a result, you might output maybe 100 gigs of data corresponding to those IPs and users. Well, to do that, you wouldn't want to have that workload be something you saddle your static worker group with. It's busy handling the load that it's sized for already. So your beats agents, the stuff that's coming in from your forwarders, things that it's pulling in from Kafka, and whatever it is. Instead, what you might want to have is a second worker group that is specifically there to handle these dynamic workloads. So this is a place where Kinesis and other kinds of orchestration like that really, really make sense, right? So by default, I'm going to have a single log stream worker just sitting there waiting for something to happen. And the way that actually works is that one first initial worker is going to phone home every 10 seconds to the master, which we see up here. And every time it does a phone home, it's saying, is there anything for me to do? Now, in this case, we haven't configured these guys to listen to any push-based sources. They're just sitting there waiting. So for the most part, it's doing nothing. And the log stream at one point the worker is going to phone home and it's going to talk to the master, and the master is going to say, I have a discovery job for you. Go forward to S3, and in this bucket, for matching this filter, and from this time range to this time range, bring stuff back. And so the log stream worker's discovery process will go over to the S3 bucket, and it'll find everything that matches the main filter. So in this case, the filter is anything tied to the partitioning. And that might come back with hundreds or thousands or even millions of file objects. And that one log stream worker passes the results of that back to the log stream master. And it's going to hold on to a queue, a work queue that this dynamic worker group will then pull from. But as that worker was doing that discovery job, it's now using more of its CPU load. And depending on how you've got your dynamic scaling to work, this worker group is now starting to spin up additional workers, or at least one, so that that worker group is now ready to handle what comes next. Next phase is, let's say I've got 500,000 file objects to be collected. That worker, original worker plus the one that's sitting next to it now, they'll phone home and say anything for me to do. And the master has its queue of collection jobs to be done, one for each file object. So each logstream worker will then reach over to S3 and it'll start collecting things with as many threads as it has available. And very quickly, those boxes are going to go from no available workers to as many available workers as exist in that group. This in turn will cause that group to scale even farther, up until the limit of the number of worker groups that you have in your auto scaling group. So that might start from 1 and maybe you want to cap it at 10 or 1 to 20. Eventually, you're going to have this group as full of workers as is possible, necessary to pull out data from S3 at the maximum rate supported by S3. At some point, though, you'll get to a point where each of the workers has its last job. That queue that the master is holding for that worker group from that original discovery job has now finished. And after a specified period of time in your dynamic scaling, these workers will all get shut down one by one by one until you're back down to the original one. So in this way, you've handled a workload of, say, 10 terabytes worth of data that needed to be processed. The dynamic scaling has ramped itself up to handle the workload, completed the job, and then scaled itself back down. One last nuance in here is that what would happen if a worker disappeared from this dynamic worker group accidentally, or it got shut down perhaps when you were near the end but not quite at the end. Little piece about the jobs. The collection jobs all have a timeout. So when any given worker talks to the master and says, "I've got this," then the master will wait a specified period of time for that collection to complete. If the worker gets shut down abruptly for whatever reason, then of course it times out, and the remaining workers will then see that job in the queue again. So one way or the other, you're going to end up catching that data, and when you're done, everything will scale itself back down to nothing. I hope that all makes sense.
And when the worker that was down comes back up, let's just say it was accidentally hit the reset button or whatever. When it comes up, will it try to get that same data that it was working on previously? Again?
Well, in the case of the dynamic worker groups we're talking about here, maybe they're orchestrated in Kubernetes. Those instances are all ephemeral. It has no idea that it didn't exist before. Somebody hits reset button, it's gone. It doesn't have reincarnation. It's just dead. So in that case, so no. If you had a more traditional VM, that wouldn't be in that concept of dynamic anyway. But if it did come back and it had some kind of retained state, it would try and collect something that had already expired, and it would do the right thing at that point. It would phone home to the master, see that that job no longer exists, and silently go forth trying to do whatever it does next.
Thank you.
Okay, so unless there's questions about that, I'm going to move to the next little piece, which is about sizing. Okay, well, then I've changed my view here a little bit to a multi-site Cribl deployment. And there's a couple different things that I'm showing here, but I want to first use this as a way to talk about sizing. When you size your Cribl environment, what you should think about first is, what is the right way to set up my logstream worker groups? Where should they live? What should they be doing? If it's a static workload, which is what we're going to size for here, in that static workload, what's the total volume that I have to deal with? So here I've got a multi-site environment. Maybe it's a multi-cloud environment. So I might have some AWS over here. I've got some Azure over here. Maybe this is GCP. Or these might even be, more traditional on-prem data centers. The main site could be in the cloud, it could be on-prem. It doesn't really matter. In this case, some of the examples up here, like the S3 MinIO, that would be an on-prem deployment. But everything I'm talking about is kind of divorced from that concept of whether it's physical or in the cloud or in New York or what have you. When I size this worker group here at site A or B or B or C or D, what is important first and foremost is to analyze the sustained workload that that's going to have for data coming in, as well as data going out. So in this case, this is from one of our federal customers, and in their case, they have, you could think of them like research labs that are distributed around the world, and each lab has its own ability to Splunk or use Elastic to analyze the data from that particular lab. So they've got some data that's being collected maybe via beats over here and via forwarders over here. But in their environment, what they want to do is have the ability to have local analysis and at the same time also forward security related data out to some other destination. Why this is happening isn't as important as the sizing. So in this case here, let's say I've got data coming in from, I'm going to make up a number, 5 terabytes worth of data per day coming in. And after volume reduction of say 30%, I've got 70% of that data going over to my local Splunk instance. And maybe I've got that same 70% going over here. So I have 140% going out of the 5 terabytes, which that's 7 terabytes going out and 5 terabytes going in. The total is what you have to size by. So if 7 out and 5 in is the total, then I need the logstream worker group to handle a total of 12 terabytes. From there, it's pretty simple stuff. It's 400 gigs per core per day. And that's against the aggregate. So at 12 terabytes, that's 30 cores that you're going to need overall. So 2 16 core systems sounds like it should handle the load. But if I was going to design for resiliency, I'd want to have a third 16 core system. So not exactly like it's shown here, but 3, so that if one's down for whatever reason, if this is a traditional VM, if one's down for upgrades or what have you, this will allow me to continue to handle the sustained workload for that environment with 1 down. So again, just to recap, size all the inbound, all the outbound, and then divide by 400 against the actual number of cores. Now, these days, most people are working with vCPUs, virtual CPUs, which include hyperthreading. So the way to think of a vCPU is about half of 1 core. Now, we're being extremely conservative when we say that. It's assuming that vCPU, that hyperthreading is getting you actually nothing. And that's not quite true. So in some cases, you might get 10 or even 20% additional throughput out of a vCPU. But we feel that it's always better to scale based on a conservative estimate and overscale the environment than it is to underscale it. So said more completely, if I had 16 true cores, that's 32 vCPUs. And I'm going to treat them as if they're the same. So in this environment, that's what I'd be setting up in terms of my VMware environment, or EC2 VMs or Azure VMs. One last piece before I move on is that if this was instead of local Splunk, maybe I'm pulling data from AWS down here. Site B is AWS, and I'm pulling data out of Kinesis, and I'm pulling it out of I don't know, VPC flow logs and SQS notifications to go pull up certain kinds of things. But maybe I also have data that's coming from that environment that is maybe universal forwarders running in EC2 VMs. All that data could be coming to the logstream worker groups that are there first. And maybe everything that didn't originate from S3, I want to archive to cheap mass storage back to S3. So they may not have that local Splunk environment, but I might have a subset of the data that's being pulled, the things that are not pulled from S3. I want to write it back to S3. Over here on the right in Azure, maybe I'm pulling that data out of the same kinds of sources, but I want to write it to cheap mass storage. So keep it there in blob storage. The idea here is all about minimizing costs for data egress. So if I'm going to use cheap mass storage to retain data, I want to keep it as close to where did it originate as possible. So whether it's GCP or Azure or AWS, use the local storage that is native to that environment to archive back whatever it is I might want to replay at a later time. So I'll pause there and see if y'all have any questions. And then I have one more topic to cover past that. 3, 2, 1. Okay. So then the last piece is data egress. So if I had a multi-cloud environment, and again, this might be AWS and Azure and GCP or whatnot, and maybe I want to send all that data to an on-prem traditional deployment, or I want to send it out to a particular cloud instance also in Azure or AWS or what have you. When I'm taking data out of one provider, one cloud provider, and sending to another, they will charge you to egress that data. And this could be in the millions of dollars a year. And if you can compress that volume before sending it out, then, let's say you were able to get a 10-to-1 compression. This would easily save you 90% of your data egress charges for this use case. Why wouldn't you want to do that, right? So here we're showing one way that you could achieve that goal. So first, if I am pulling data back in or receiving data initially from all these different sources here, let's call this guy, I got blob storage. So let's assume this guy over here is Azure. I've got data coming in. I'm going to do some volume reduction anyway, maybe drop that 30% of logs that are usually junk anyway. And then what we can do above and beyond that, as I send the data across the wire, is to do wire-based compression. So that's using gzip streaming. And so that gets you about 8-to-1, up to 10-to-1 compression. So between the two, you're certainly over a 10% compression, but factoring the 30% drop on raw, as well as the 8 to 10 to 1 compression that's going at the next step. So in this way, I've got local logstream workers here that are then sending their data out to this receiver worker group. And this is a dedicated worker group at whatever the main site is where perhaps I want to collect all my data. And this group's job is simple. It's to just catch the data as it's streaming in from these other worker groups. And it's sized based on the needs of the output for each of the worker groups that are feeding to it. Notice that I'm not saddling it with the additional duties of handling these guys over here. It's a different worker group just because it makes it a little easier to support. Over here, you're going to make changes occasionally, just as you might for each of these other local groups, to reduce volume, to add new sources, and so forth. This group, on the other hand, is pretty static. So you set it up once, it's sized correctly, you set it, you can now forget it. So another reason why you might want to bring it this way, you might be thinking, well, why don't I, if this is going to go to Splunk, why don't I just send it to Splunk, right? Well, this gives you the chance to do centralized collection, and then perhaps optionally send it to S3 if you wanted to do that collection locally on MinIO on a local file system. But also maybe this data is coming in and you actually want it to go not just to Splunk, but maybe to Elasticsearch or some new tool farther, into your future. So by bringing it into a single location first, this then allows us to have collection regardless of the protocol and the agents that were necessary to do the collection. Again, down here, we were using Beats agents perhaps, and over here, we've got universal forwarders. We've collected that all to one place, and now we can send that data wherever we want it to go.
Looks like we got a question in the chat from Eugene.
Okay, great. Let's hear it.
When the second work group gets the data from the first, does that count against license second time for the same data?
It does not count against license second time for the same data.
And feel free to interrupt. Go right ahead.
Yeah, I'd love to hear your voice. Just shout it out.
I figured I'll queue it up for whenever there's a chance to answer it. So.
Yeah, that almost felt professional the way that happened. So thanks for using the chat. But today, it's just a handful of us, so we can do it this way instead. Did that make sense though, in terms of this? Eugene, have you guys looked at the data egress charges in your environment for pulling things out of AWS or Azure or whatnot?
We're not that far along. It is something in the back of my mind. I know InfoSec is trying to bring in, for example, CrowdStrike data. I don't know if that is something that we can have a worker group in the cloud handling that. I don't know enough about how that works, right? So can we process it up there before sending it down, or does CrowdStrike already include, log egress as part of the license? No idea.
Yeah,
But it's something I'll ask them.
Yeah. So, and I don't know CrowdStrike enough, but I can, let me speak to Carbon Black, because I have one customer who's doing that. So if AWS is site B over here, Carbon Black for one of our customers was a huge data set. So all their on-prem endpoints, all their remote workers that are, everyone's COVID right now, working from home. So all the Windows machines are they're streaming their security relevant data out to a cloud hosted version of Carbon Black. Carbon Black makes the logs available by dumping it into S3 buckets in AWS. And the data for at least one of our customers, so if you think about that data, it's landing in S3 up here, but in their case, they wanted to get that data over to their VMs, which for them were hosted over in Azure. And that's where their Splunk environment happens to be running. So let's call main site up here is Azure, and site B here is AWS. So in their case, it was pretty simple. They sized the local worker group to the workload that is tied to everything that was over there, including the Carbon Black data set. For Carbon Black, they did an analysis of the data that was in that data set, and they determined that about 60%, 70% of that was not useful. So by either dropping events or by dropping portions of events, they were able to whittle that down to 30 to 40% of the original volume. And only that needed to then be egressed out to Azure. And so we're down to 40%. But by the time you take that 10-to-1 compression, now you're down to 4% of the original volume in terms of what's traversing this pipe here. So going from 100% down to 4%, obviously saving 96% on that price tag for a particularly large volume source like that could save a ton of money.
That makes sense.
Yeah. So to recap, right? Collect data as close to the source as possible. Do the volume reduction as quickly as you can. Use the most efficient protocol with wire compression to send from site to site. And then once you've got it over to where you want it to be, these guys are going to then decompress it off the wire. And by the time it lands in Splunk or Elastic, it looks just like it should, right? Those guys don't know that it didn't come from a heavy forwarder sitting on the same subnet. It's just, you'll have all the benefits that come with the volume reduction and so forth.
Makes sense. And I see in this diagram the master sits in one place, right?
Yeah. So
even if the worker group is up in the cloud.
Yeah, right.
Okay.
And the master could live wherever makes sense for you, right? So that might mean that even if I was on the phone today with an international company. They've got data centers in 5 different locations around the world, but they're also in Azure, and they're also in GCP, and they're also in AWS. And they said, well, which one of those should we put our master in? I said, the one everybody can access. And so that meant any of the cloud hosted things, but they didn't want to run it on-prem because that would have meant poking a hole to the on-prem master instance for these cloud hosted things. And, they had something with AWS setups for the virtual VLAN behind the scenes, but not for Azure and GCP. So great, stick it out there in one of the cloud environments. Doesn't matter to us.
But they didn't have any workers running on-prem, so they didn't have to poke holes.
Well, so you should, oh yeah, let's talk about that. Workers talk to the master, never the other way around. The master never ever establishes a connection to a worker. It's only ever phone home. So these, in terms of command and control, each one of these workers is phoning into this guy every 10 seconds saying, is there anything, is there a new config for me to pull down? And are there any jobs for me to start working on? So you don't need to poke holes inbound into an on-prem environment for the master to talk to the workers, because that's just not a thing.
So the same thing then when you're deploying, it's the workers that are pulling the new configs down?
Mm-hmm.
Okay.
Yeah, so that master can be wherever it is. And so long as you open the 2 ports that are necessary, by default, that's 9,000 and 4,200. If I had 3 on-prem environments, I might specify what are the IPs of those. You can also, of course, say that that box is only going to listen on, by default, it's not encrypted and it's not password protected, really. We ship with a password, but it's the default. You can lock that down and should lock that down if that was a host that you're going to expose out to the internet. Like that question.
Okay.
Yeah. So, and then in terms of the rest of it, not shown on here is that kind of dynamic scaling. One cool thing that we released a couple weeks ago is a Helm chart. So this is an automatic scale up, scale down configuration for a Kubernetes-based worker group. So if that's something that you're looking into or excited about the possibilities of, you might start there, take a look at that Helm chart. And then, if you need help from us to adapt it to your environment, we'll be happy to do that as well. All this is going to continue. We're doubling down on dynamic scaling up and down. 2.4, the next version is coming out middle of January. And you'll see that this becomes part of the mainstream functionality inside the product. And because we're talking about Kubernetes, the standard way for you to monitor a Kubernetes environment is with Prometheus. So we are adding native Prometheus support in 2.4 for scraping performance data about the health of your Kubernetes environment. And we'll also offer as a destination in Logstream a Prometheus publisher, so that if you have other things in your production environment that need to reach in and collect Prometheus data, things like Grafana, they can reach to Logstream instead of having to go to all the original data sources natively. So that's what I've got for today. So we can turn this back into general Q&A, talk about any topics you want.
Did any of you come with some questions already? And I know, as someone has pointed out, that you can ask them in Slack as well, but this is a different interface. Feel free.
Well, knowing that the new target for 2.4 is mid-January is good, because there are a bunch of things that supposedly are coming in it. So
yeah, we'll definitely have another one of these a little after we drop the next release, right? So that you can start answering the new questions. There's going to be some new surface area for sure to be going through. So we'll expect you to come with questions. I'll have a checklist.
For next time, we'll challenge everybody. Come to office hours with at least one question.
Yeah, maybe there'll be prizes. Who knows?
The price of admission is one question.
About the product. Not just any questions. We'll do our best, though.
I'm just thinking, since we have no specific agenda, so if you have the master in the cloud, we're talking about it having a Git repo, so somehow that conversation, right, that connection needs to be there.
Mm-hmm. Well, in this case, keep in mind the master always has a local instance of Git anyway.
Right.
But almost everybody that we're working with today, certainly anyone with a more advanced deployment, has either they're using GitHub or they're using a centralized internal Git repo wherever it lives, and we don't care.
Mm-hmm.
And so the master, obviously, anytime you hit commit and deploy, we can do a write-only copy of that information out to the Git repo at the same time. That also keeps all of the information about everything that is being managed through the GUI. So the certs are pushed to the Git repo. All of the pipelines are pushed to the Git repo. All the routes, sources, destination, all the configs. And so if you needed to reconstitute the master from scratch, all you really need to do is clone back down from Git into the right directory, and boom, you've got almost everything. The only exception to that is a single security key that is necessary for decryption of the passwords that are being stored. So Git plus that one file is all you need to reconstitute the master. And anybody who's interested in DR type of scenarios for the log stream master, what if it gets blown up? Whatever. Just what we recommend, of course, is to have an automated process that spins that box up, typically within a couple of seconds. Particularly facilitated if you are in some kind of cloud environment. And by cloud, I even include on-prem cloud like VMware, if you're using orchestration with it.
Okay. Yeah, what ideally I would like, and I come from background of software development, I would like to have a dev environment where you can mess with things, committed to Git, our internal central Git, and then do a pull request, code review, whatnot, and then push it out to the production master.
Yeah.
I don't know if that's something that's in the works.
It's in the works. We are certainly not there yet, but we use GitOps ourselves for managing everything about the way our product and our company operate. So certainly we've got that on our roadmap. Today, you could do the same kind of thing, but with a more manual approach, where the same one log stream master might also manage the dev environment as well as the production environment. And then you're just talking about moving configs from one worker group to another within the same management UI. Even that can be done with Git or through Git. But what this allows you to do, at least the way we do it today, is if you copy and paste a pipeline that you like from one worker group to another, which we support in the UI, this allows you to validate that it's going to work in production before you put it into production. That's a lot harder to do through an orchestration tool where there's no facility within it by itself to do the collection and the sampling and the kinds of processing work that you can do, the validation work that you can do through the UI we provide.
Okay.
So all the other thing that everybody's kind of excited about is role-based access control, which is before. So there's only a couple of you on the call, but if you'd like, we can talk about. Oh, there's 16 now. Oh my gosh, look at that! It's great. So if anybody wants to hear, how role-based access control will be working, I'd be happy to speak to that.
I would be very happy to hear that, and I'll even let others chime in with their opinion and not monopolize.
Yeah. And for anybody who's just joined, feel free to take yourself off mute or post to the chat, whichever way makes you more comfortable. So role-based access control in the 2.4 version is going to be pretty straightforward. For each worker group, you can designate that any given user has full admin access, read-only access, or no access. And it's not granular down to the level of a source or a destination or a route or a pipeline. I'll explain why in a second. But what we are able to do with 2.4 is to say, if there's this worker group, you will now be able to get into it, or you can't, even though it's all in the same log stream master. Up until 2.4, the way we supported the equivalent kind of functionality was to simply have different masters, one for each environment. And you could log into this master, but you couldn't log into that master. So does that make sense?
It does.
Okay, and so the reason why we didn't go as granular as a per pipeline or per route basis is because of what that would mean in terms of supportability. So if I were to say this person has the ability to edit this pipeline, but they can't even see that pipeline, then if you're using the full preview mode, for example, you might not be able to see the information that would allow you to determine whether or not other routes ahead of your route could have grabbed that data and then sent that data into the pipeline that you've got. So you have this whole set of dependencies between knowledge objects like lookup files, pipelines, and routes, and those all work as a whole together. And so being able to have specific granularity down into just one of those aspects of it kind of breaks the ability to see the entire dependency tree as a whole. So at least for now, we're giving you role-based access control on a per worker group basis. Now, in this diagram I've got up here, imagine that I had site A and B, well, sites B, C, and D. I might give full admin rights to the people at each of those sites, and maybe I'm giving them read-only access up here. This would allow them to control what's being sent back to the main site. And maybe they want to ramp that up or ramp that down. But we see this a lot of times where there's a parent company with subsidiaries, and where they want to allow each subsidiary to control what's being sent on or not being sent on. So in this case, site D over here, they're running Elastic, and the other guys are all standardized on Splunk. And that's fine. You know, this way they can set up the ability to receive in all the ways that they care about. And the guys back at headquarters don't have to worry about what it takes for them to set that up. They are able to be relatively autonomous, even though the master is back there at headquarters. They hit commit, deploy, these systems come live. Now they're maybe sending more data over this pipe and everything's fine. They can then go over to this worker group in read-only mode and verify through a capture that the data is coming in as expected from this site, but they're not able to do something to screw up the configuration by maybe the admins here don't trust them. And so they haven't given them full write access, but they have the ability to do the capture and do the analysis. Another way of deploying with the role-based access control is to kind of flip this around. And we see this sometimes where a customer has centralized configuration today, and it's all coming to a single place. But then one team or another has said, hey, we want to have access to some of that data so that we can send it to our own system of analysis. Everything's going to the security team for Splunk, that's fine, but we also want to get a copy of it over to Elasticsearch because we're the app development team. So in that case, you could imagine reversing the arrows here. Data comes into a centralized logstream instance, and then based on agreements that are made between the individual teams, might say anything coming in that's from this application stack or from these servers is going to then be sent out to a local worker group that's completely managed by that other team. So central logstream admin team has said, we're going to send you a stream of data. We're going to set you up initially so that your default route is just dev null, but then you can take from that full set of data, you can take the subset you care about and route it to wherever you want. And so there too, the individual teams that have admin rights down here, maybe you don't even give them read access up at the top level, but this allows you then to support that kind of delegated ability to send data outbound to the teams that want it so that they can do whatever pipelines they want with regards to that data. Okay, so that's role-based access control in a nutshell, and a couple of the ways that you might consider deploying it. For those of you who joined a few minutes after I started presenting, today is really just general Q&A. So if you have any questions at all on any other topics other than what I've already covered, by all means, it's an open forum. Feel free to ask. Take yourself off mute, just shout it out, or put it in the chat.
Wow, everyone is super knowledgeable, clearly.
Maybe it's that community Slack channel we've got that
Yeah.
getting answers already. If there's anybody who's on this call who didn't find out via the community Slack channel, then know that we have one. If you're able to join, it's a great way to get answers quickly and to see what some of the other people are using the product for today. so that, perhaps it inspires you to do something a little outside of what you're already doing with Logstream.
Yeah. And like I said, we'll definitely host another one of these right around the time that we ship the next release. And maybe that's going to be, we'll figure out some regular cadence for these. And yeah, there's a link in the chat. Thank you, Cam, to join the community Slack if you'd like to join it. But I think everybody in here is already on there. So thank you very much, everybody. Appreciate you attending the first one of many, and we'll talk to you again next time.
Is the recording going to be posted somewhere we can share?
I'm not sure. I'll ask about that. We were actually recording it for someone internally, but I'll ask.
I'd like to share it with the rest of my team, at least internally, if possible.
The reason why we wouldn't, I like to ask. I'm still relatively new.
Yeah, Eugene, if it's okay with you, then we'll share it with everybody. You're the only one asking questions. And then for hygiene for next time, we'll make an announcement up front that we are recording it and that it will be made public. But for today, I think that this is, unless there's somebody on the call today who would prefer this not be shared with everybody.
My existence must remain unknown. Yeah. Cool. And you've got the file, right? You're the one who started the recording, Michael.
Apparently it's going to the cloud.
Okay.
And we'll be able to share that cloud link, within about an hour after this, after we stop.
Awesome. Whoa, no thumb. Cool. Well, thanks everyone, and we'll see you next time.
Okay.
Thank you.
Bye, everybody.
Thanks.